So, as I was saying, we're not going to worry about the back side of today's opener. We're just going to focus on the front side here. The first thing that I'm going to do in order to factor this is find the MA. Can someone tell me how to find the M first? What do I do with them? Yeah, so I'm going to multiply my first coefficient and my last coefficient. Remember, coefficient means the number. Now, my first coefficient, there's nothing there, but there's a variable. If it's just a variable, what's my coefficient going to be? 1. So 1 times 14 is 14. Jemiah, what's my A?
9.
Just the 9. It's just the coefficient, just the number. Good. So this is where you use your blue cheat sheet, your little factor sheet. You look at the number 14, and you look to see which of those factors can you add together to get 9. 2 and 7. So if I take 2 times 7, I'll get 14. But if I take 2 plus 7, I get 9. From here, I begin to fill out my area model. What do I start to fill out in my area model first? I know I'm going to start filling out the rectangles, but what number am I going to put in the rectangles? What does that represent? The area. Good. So what's the area of my top left rectangle? This one right here. X squared. Okay. Top right. What's the area of this rectangle? 2 or 7. What variable goes with it? X. Bottom left? 7 what? Now you guys realize, basically, the 2x and the 7x, that makes my middle area. That's where that 9x we don't use because we broke it down and got that 2 and 7. Okay, and what's my last area? 14. And there's not a variable with it, so it's just 14. Perfect. From here, I now have all the area, so I have 2 more things I need to find. I need to find the height and the width of my rectangles. What's the first one I'm going to find? The height. How do I find the height of this top row? No, help them out. Factor tree. Yeah, you guys are both right. Greatest common factor. So, because it's just a variable, there would be a 1 in front of it. What would be the greatest common factor for 1 and 2? 1. And what variable do they share? X. So it could be 1x, or you could just simply put x as well. So the height of this rectangle is 1x or x. So I'm going to plug in my heights, and now I'm going to find my width. So 1x times what will get me to x squared? Yeah, just x, or 1x. It doesn't matter how you put it. You could have x, or you could put that 1 on there. Then I go to to find my next rectangle to find my next width. 1x times what will get me to 2x?
2.
What do I do with these widths now that I found them? Bring them on down into the second position, the second spot, right? And now I need to identify what my height is going to be for my bottom row of rectangles. So what times x will get me to 7? Sorry, what times x will get me to 7x? 7. If I plug in 7 here, will 7 times 2 equal 14?
Yeah.
Yeah, so what's the height of my rectangle down here? 7. Ooh, that's an ugly 7. We have to rewrite that. Okay. Now I'm ready to write out my final answer. Now, if I tell you I want this in simplest form, what would that mean? If I want... Huh? I'm going to write the whole thing up there, but am I going to add that 1 in there with that x? If I want it in simplest form? Nah. So let's write it out in simplest form. So, area equals height times width. What's my height? X plus 7, because we're writing it in simplest form. If you put the 1 in there, would I mark it wrong? No. And then what's my width? X plus 2, parentheses, box it. There's my final answer. Now, this today is going to lead into what we're going to talk about, fast factor. We're going to be able to fast factor when there's not a number for our first coefficient. So you're not going to have to do all this extra work. I'm going to show you a shortcut called fast factor.